Hey, Natty Grace.
Hi.
I am uploading some documents right this second, so I have what we need to go over. Did I email you everything yesterday?
You emailed me the study guide and practice A.
Okay.
Is that it?
Yes, ma'am.
Okay. Cool.
So I'm going to try and pull those up. Internet's just being a little slow.
That's okay.
There we go.
Cool.
Okay. I went over a little bit like of the study guide in class yesterday with everyone, and
Okay.
we also worked this practice A kind of simultaneously while we were going through the worksheet. And I did change some of the directions on the worksheet. So what I'm going to try to do is just go over what we did yesterday, and then find out if you have any other questions over possibly 9.3 also. Have you watched that video yet?
I did, but it was kind of difficult to understand.
Especially probably skipping this piece.
Yes.
So maybe, that will help, if we go through this a little bit. So first of all, in the box at the top here, this piece is the part we're going to talk about first, the ax squared plus bx plus c. On Monday, all of our problems were actually in y equals ax squared plus c. So you can see that the part that was missing on Monday, the difference between Monday and Wednesday, is this bx in the middle. And with the ax squared plus c on Monday, we saw that when we were drawing these parabolas, we had the parent parabola that looked like this. And then this c part would tell us to either move up or down on the y-axis. So if it told us to move up, if it was like +4, it would be there. If it was a -2, it would move down. And so this C is what had us go up and down on the axis. And the A made our parabola like the parent. If the parent looked like that, if it was 2x squared, then it would be skinnier. It would rise quicker. Okay, that's kind of what we talked about on Monday, just to give you a review of that. Now, yesterday, we learned something new with the BX added, that that will actually, so what we call those when the parent graph shifts like that up and down the axis or gets fatter or skinnier. The other thing that we did talk about, I want to say, is that, you know how on Monday I said if it went like, if the parabola went like that, if it was y equals negative x squared and that leading coefficient had a negative on it, was a frowny face. We talked about that because it was negative, it was frowning. I gave the mathy word for that yesterday because I'm trying to introduce how math people speak it, not just how it is. It's called reflected across the x-axis. I wanted to make sure I addressed that with you. But what we're learning about now is that when this middle term gets added, our vertex, which is on that parent graph, the vertex or that pivot point is always the origin on the parent graph. Well, now with the BX term, it's telling us that that vertex can actually shift. And the axis of symmetry on Monday with the more simpler quadratic is always the y-axis. But now with a new vertex, because of the BX term in the middle, the vertex will change, so therefore the axis of symmetry will change. And the axis of symmetry is the x in, like, the vertex will have a x and a y coordinate, and the axis of symmetry is always a line, documented x, which will be x equals, like, oh no. Okay. My unfortunately, every now and then it pauses on, like it popped for some reason, and I have to start all over.
That's irritating.
Oh, you have no idea. I'm like, please don't do this to Natty, Grace, and I. Okay. So the axis of symmetry for this one would be x equals 0 because it's the y-axis. But this tells us how to get an axis of symmetry on a quadratic that has this bx or this middle term. But what we did in class before we got started on that is we actually went to the practice A. Do you have that in front of you by chance?
Yes, ma'am.
Okay. So what we did is we just walked through to make sure that we could pull out successfully that A term, the B term, and the C term so that we understood going through this exactly what those are.
I was able to do that.
Okay. So you got, for number one, you had A equals 7, B equals 2, and C equals 11. You don't put the X with it. You just put the coefficient all by itself. Does that make sense?
Yes, ma'am.
Okay. And you made sure, like on number 2, when you were doing A, B, and C, you had 3, -5, and 1?
Yes, ma'am.
Okay, because you want to make sure you pull those negatives with it. That's really, really important.
Got it.
Okay, because that's going to change everything if you don't pull the negative with it. Does that, especially when we're finding our vertex, because our vertex and our axis of symmetry in this particular section has a formula with it, and that goes along with example 2. Okay. No, I believe that's example 1. My apologies. And let me erase this over here, because I don't think on the practice sheet I have enough room to do all of the problems. And I was a little late for math lab. I was trying to go for 2, but math lab for algebra 2 lasted a little longer than I thought it was going to.
It's
So
okay.
lots of questions. So that's always good. I love it when students ask questions. So for
I do have to leave at 3:30 because I have a dress rehearsal. I have a dance competition this weekend.
Oh, okay. Well, let's get through this as quickly as we can then. So, on number 7 through 15, it says tell whether the graph opens upward or downward, and then find the axis of symmetry of the graph of the function. Okay, opening up or down, we did talk about that a little bit on Monday, but that's simply driven by whatever the sign is on the leading coefficient. So if the sign is positive, it opens upward. If the sign, and so number 7, the answer would be upward. On number 8, the sign is negative on the leading coefficient, so it would open downward. Okay?
Got it.
All right. Now, the axis of symmetry for both 7 and 8, those are exactly like the ones that we did on Monday. So in that case, really all the difference is on like x squared plus 6, it's the parent graph, but it's shifted up by 6 units. So the axis of symmetry is the y-axis. So the axis of symmetry is x equals 0 for number 7. And it's the same for number 8. Number 8, the only difference is that it's going to be shifted down 1 unit, and it's going to be a frowny face or opens downward or reflected across the x-axis. So it would look something like that. But the axis of symmetry is still x equals 0 because there's no bx term.
Got it.
All right, so now number 9. There's a formula that tells us what the axis of symmetry is. And that formula is opposite of B. And I say opposite because if B is negative, it's obviously going to be the opposite of a negative number. So I don't really say negative B. I say opposite of B over 2A. So what we'll do for number 9 is pull out the B term, which is 6. So it's the opposite of 6 over 2 times the coefficient here, which is an understood 1. So that's going to be negative 6 over 2, which then reduces to negative 3. So the axis of symmetry is x equals negative 3.
Hey, I got that right.
Good. Awesome. Okay. So how many have you worked forward?
I've done through 24.
Oh, you've done through 24. So you didn't have trouble with the vertex or anything?
No, ma'am.
Okay, good job. So you knew to plug in whatever you got for x to find the y.
Yes, ma'am.
Oh, awesome. Okay, so number 25. The quadratic function, use the quadratic function to complete the table of values. So on that one, you're just going to plug in. So like for this one, you would plug in 1. So you've got 1 squared, which is 1, minus 6 times 1, which is 6, plus 8. So I've got a negative 5 plus 8, which is going to give me a positive 3. And then I'm going to go with 2. And 2 squared is 4, minus 6 times 2 is 12, plus 8. I've got negative 4 plus 8, which is 4. And you just kind of keep doing that through all of the tables.
So is the first one, all the y's are 3, 4, 5, 6, and 7?
I haven't worked that one completely out. Let me check it out. Hold on just one second. It kind of sounds like it might be going in that direction to me, but let me just double check because I haven't, like I said, I haven't worked all of those out. What number is that? 25?
25.
I must have done something wrong.
I think.
No, I think I did something wrong in my quick math. 4 minus 12?
The second one is 0.
Yes, it is. Because 4 minus 12, I must have just said 6. That's what I did wrong. My bad. It's 0. Good thing I looked it up. Because it's 4 minus 12, which is a negative 8 plus 8. That's 0. And then 3 squared is 9. Let's see if my simple math is any better this time. Minus 18, because 6 times 3 is 18. So that's going to give us negative 9 plus 8. So that's going to be a negative 1. Is that what you got too?
Yes, ma'am.
And then 4 squared is 16. Minus 24 is 8. Plus 8, that's going to be 0 again. And you know what? I'm going to guess
3.
Oh yeah. Yes, because it has to mirror. So this is the vertex. That's what they're trying to get you to do, is to figure that out. That's going to be the vertex, and this is going to be 3, because those points are going to mirror each other. And so then you would, on 26, you would just plug that in. And I believe the answer is, let's see, the opposite of 4 squared is negative 16 plus 48 minus 5. That's going to give you a positive 27. So you kind of keep working through those like that. And that's just a matter of doing those. So I just kind of want to move forward since you've got to go at 3:30. On these, number 29, 30, and 31, because this number 25 through 28 is just plugging in values, and I know that you know how to do that. Match the function with its graph. So what you're going to want to do on these is find the vertex and the axis of symmetry. So you've got the opposite of B, which is 2 in this case, over 2 times A, which that's going to be a negative 1/16. No, negative 1/8. Negative 1/8.
Would that be C?
Yes. That's weird. Because that doesn't look like... Oh, yeah, it does. It's a negative 1/8 right there. That's the only one that looks weird like that one. So, yes. And that's going to have your axis of symmetry also there. And it's the only one close to that. And so this is C. And then this one is going to be the opposite of 8 over 2 times 2 is 4. So that's going to be a negative 2. So that's either one of those or the possibility. So you've got to figure out, no, because this goes by 4. This goes by increments of 4. So this one is the only one that's on the 2. So this one would have to be B, which automatically makes that one A. All right, and I'm going to go back to 32 through 37. in just a second, but I want to skip down to number 38 through 40 because that wasn't in Tuesday's video. So I want to make sure I cover that. And I also want to tell you, I'm not asking you to find the value yet. I'm just asking you to tell me whether it has a minimum or a maximum. And you do that based on the leading coefficient and whether the parabola opens up or down. Okay? So on the first one, the leading coefficient is positive. So it's going to open up.
So it has a minimum?
So it has a minimum. Good job. The leading coefficient is negative on this one. So it's going to open down and thereby would have a maximum. And on number 40, it opens up also. So it's going to have a minimum.
Got it.
Okay. Now let's go back to number 32. Label the vertex and axis of symmetry. So on this one, it's going to go down 6. So here is going to be my vertex right here. And it's negative, so it's going to open down. And I'm not looking for an exact science, but I told the class this yesterday. I only need 3 points when you're graphing a parabola. I need the vertex, which in this case is going to be 0, -6, and then give me one other one. So if I use the number 1, that's going to give me a -1. So if I use 1, it's going to give me -7, or if I use -1, it's going to give me a -7, but if I use 1, it's going to give me a -7. Or yeah, -7. So, and I didn't do very good about getting it through the point, but that's how that would look. Does that make sense?
Yes, ma'am.
Okay, so on this one, it's going to go up 7. And the 2 points are going to be 1 and 8. And -1 and 8. And drawing on this is not very easy, but basically that's it. Okay, number 34, you would find and your axis of symmetry on these is this. And it's supposed to be a dotted line. So my vertex is 0, -6, and my axis of symmetry is x = 0. My vertex is 0, 7, and my axis of symmetry is x = 0 on 32 and 33. My axis of symmetry here is the opposite of B, which is 2, over 2 times A, which is 1. So my axis of symmetry is x = -2. And then what I do to find my y is plug it back in. -2 squared is 4, plus 2 times a -2, which is a -4, plus 5. So my vertex is -2, 5. And using 1 as my point, 1 plus 2 is 3, plus 5 is 8. And it would mirror. Lord of mercy. The struggle is real today with me and simple math. Mm, 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 mm. When I started graphing that, I was like, that's when I caught it. Help me, Jesus. It's so funny. I watch a lot of videos, before I figure out which one I'm going to give y'all. And I see other teachers do that, and it's made me feel better. Yeah, baby. Studio Crush? Now, that'll probably make a difference. It's a certificate. She's a certified makeup artist. It's kind of like an associate's degree. Okay, sorry about that. My drawing on there is so bad. And then for number 35, we've got the opposite of -8. Let's see if I can do simple math better this time. Over 2 times 1. So I've got 8 over 2, which equals 4. So x equals 4 is the axis of symmetry. And the vertex is going to be 16 minus 8 times 4 is 32 plus 1 is -16 plus 1, which is -15. So it is going to be right here. And if I plug in what do we want to plug in there? 1 minus 8 is -7 plus 1 is -6. So 1, -6. So we've got that. So a mirrored point is going to be about right 1.5 over. Be about right there. So I can draw my parabola. Does that mirroring make sense to you?
Yes, ma'am.
Okay, good. You're probably already ahead of me, aren't you?
A little bit.
Yeah, that's what I was going to say. So are you finished?
Yes, ma'am.
You are?
Mm-hmm.
Do you want me to keep showing you the graphs so you can check them?
Yes, please.
Okay. All right, for number 36, that's a fun one. Did you get fractions for that one?
Yes, I did.
So we've got 1 over negative, or like 2 times a negative 2, which is going to be a negative 1/4. How fun is that?
Not at all.
Everybody's probably excited that I gave them that problem. Okay. And then you plug in the 1/4. So 1/4 squared is, yay, 1/16. Negative 2 times 1/16 plus 1/4 minus 3. So it's negative 2 over 16 plus minus, okay, so negative 2 plus 4, that's going to be a negative, that's going to be a positive 2/16 minus, wow, did you get that?
I reduced it.
Yeah, to
20.
It should be 23 over 8.
Yes, ma'am.
Yeah. Oh, wow. No one's going to like me for that.
Mm-hmm.
Did you get a positive 1/4?
I did.
Okay. I just drew it on the wrong side. And then 23 over 8 is roughly 3. So your vertex is about right above the 3. Is that what you got?
Yes, ma'am.
And then for your points, what did you pick for your points? Did you pick 1?
I picked -1 and -6.
Okay. 1, which would give me a negative 2 plus 1. I have to look at it now. So -1, -4. Is that what you got?
I got -1, -6.
For your point?
For one of my points.
So 1 squared is 1 times -2. That gives me -2 plus 1. So that's -1. -1 minus 3. So I got -1.
-4.
Yes. Which would be right there. And then 1 should be right there. So it should go like that and open downward.
Yes.
Okay. And actually what's interesting in the answer key it doesn't even come up with a point. It just draws from the vertex on. So that's kind of interesting. You and I went to more trouble.
Huh.
Yeah. Let's see. So the last one, was it as hard since you've already done it?
No, it wasn't as hard. It didn't have a fraction in it.
Yeah, and obviously, I guess an hour and a half of math lab before this, Mrs. Sparks' brain's a little fuzzy. Okay. So the opposite of -4 over 2 times -1. So the opposite of -4 is +4 over -2 equals -2. Did you get that for your axis of symmetry?
Yes, ma'am.
Praise the Lord.
Woohoo!
And then we'll plug in -2. So we've got the opposite of -2 squared, which is going to be -4 minus 4 times -2, which is going to be a +8 plus 3. So that's 4 plus 3, which is 7. Did you get -2, 7?
Yes, ma'am.
Praise the Lord. And it's going to open downward because it's a frowny face because of the negative leading coefficient. So if I plug in a 1 there, I've got a -1 plus or minus 4. -1 minus 4. That's -5 plus 3 is a -2.
Yes.
Is that what you got?
Yes. I think.
But my 1's way over there. So maybe I need to pick a different point. What did you pick as your points? Because I don't have that on the grid.
I ended up with 0, 3 is one of my points, and then also -4, 3.
Oh, well, that's a good idea to stick. You know what? That was awesome. Stick a 0 in since the vertex isn't on 0. That's so much better. So then all you have to do then is count over 2 to have your mirror. Awesome. You're a genius.
Yay.
So is that what yours looks like?
Yes, ma'am.
We had a lot of upside down ones. I guess 3 out of 3. But then you didn't have to do 41 or 42. So you're done with that one.
Oh, cool.
Yes.
Yeah, those are complicated and scary.
Yeah, well, I mean, they're not too bad once you know how to do them. And we really need to get to some of those in class because I know for you guys, those are a lot. Stuff like that's on the ACT. So definitely want to get through some of those in class. But the video for today, the solving graphically, basically what you're looking at is just where the graph goes through the x-axis. And there isn't a real good example on 32 through 37, except for possibly number 37.
Could we look at the guidance practice problems from today?
Oh, yeah, that's true. Good point. Hang on just a second. It'd be cool if we could get that in too, just before you go.
Mm-hmm.
Oh, there they are.
I got lucky. I didn't have 500 pounds of schoolwork to do today.
Really?
Mm-hmm.
It wasn't too bad?
all I had to do from yesterday was take a spiritual gift survey from freshman prep class. So,
Oh, who teaches that now?
Miss White.
Oh, cool. There's multiple ways to do this particular thing. Um, and unfortunately, I feel like this is almost the longer way to do it. But anyway, when you're, we'll find the vertex. The easiest way, in all honesty, is to factor it. Did he talk about that in the video? He really didn't, did he?
No.
Okay. That's really the easiest way to do these, but let's do this. So I couldn't remember because I had several videos lined out for today, and one of them they did talk about it and one of them they didn't. But anyway, the vertex for this is the opposite of -6 over 2 times 1, which is going to give us 6 over 2, which is 3. And then when you plug that back in, you've got 9 minus 18 plus 8. It's going to be 9 plus 8. Oh, it's going to be way off the grid, way away. So it'll be way up here. It's going to be 3 and 17. 1, 2, 3. So way up here. Why would they? I don't get it. That's why. Simple math again. Rears her ugly head at Mrs. Sparks. 1. One, two, three. So now, doing a chart of values. I'm going to try 2, which is 4 minus 12 plus 8. So that's going to give me 0. So 0. So 2, 0. And 4, which is going to give me 16 minus 6 times 4.
24.
You really want, yes, which is 24, which is going to give me negative 8 plus 8, which is 0. And then you've got your 3, negative 1. So that's where it goes through the x-axis. And then it actually should have a y-intercept of 8, where that would be 0. So your solutions are 2 and 4.
Got it.
So what you're actually trying to do is figure out how it gets to be 0. Like, what values can I plug in for x that make it 0 for y? Does that make sense?
Yes.
Okay, so that's kind of the goal of it. And then like on number 2, let's go to number 2 for the guided practice. So, and based on that, I'm going to try and scoot up and just write smaller. On this one, x squared plus x. And then I think the minus 1 was on the other side. So if I brought it equals minus 1, you really want this to be 0 on this other side. So I'm going to add 1 to both sides. Like that. So like, what values can I plug in here? And if I plugged in a negative 1, I think it works. Right? It does it. If I do negative 1, that's 1 plus a negative 1. That's 0 plus 1. Nope, doesn't work. What's our vertex? 1 over 2. Our vertex is 1/2. The vertex is weird. Oops. That is not a fun guided practice problem at all.
Nope.
I can't believe they came out of the gate so hard. Yee. Okay, so we've got 1/2 and then 1/4 plus 1/2 plus 1. Trying to find the other part of the vertex. So that's 3/4. That's 1 3/4. So roughly 1/2 and 7 over 4. So that's going to be right about there. Yes?
Yes.
Roughly. All right. Well, here's the good news about that. When it's like that and it goes up from there.
Yes.
So your vertex is 1/2 and 7/4. It has no solution because it never touches the x-axis. And your solutions are where it crosses the x-axis. When it says to solve by graphing, it's looking for the answer to the question is where does it cross the x-axis? And since above the x-axis, it has no solution. That's why I said I can't believe they came out of the gate that hard, but I think they did have an example that was kind of like that, or didn't they?
I think so.
Okay, but that's if it never crosses the x-axis, it doesn't have a solution.
That makes more sense.
Okay.
Got it.
But like I say, wow, that one was tough. And then the last one, I think I know what they're doing now. I'm tracking with them now. The last one is going to be where it touches the x-axis. It doesn't cross. So it's only going to have what they call one solution. Or they'll say, because, and we'll see this more when we get back into factoring, that when it only has quote unquote one solution, which I think the problem is negative x squared plus 6x equals negative 9. Is that right? Or 9, just 9. My bad. Okay. So it would be negative x squared plus 6x minus 9 equals 0. So then your vertex is going to be the opposite of 6 over 2 times a negative 1, which then is going to be a positive 3. And if you plug that back in, you'd have a negative 9 plus 18 minus 9. So it's going to be real high up there, once again, for that vertex.
That equals 0. So 3 is the solution?
Well, no. Yes, 3 is the solution.
Okay. Got it.
Because that's going to be where it crosses the vertex is where it crosses the x-axis. And it's a frowny face. And so right there would be the solution. And it looks like it's one solution, but sometimes, because technically when we start, Lord Jesus, please help me. We start factoring these, you'll see that they'll call it a multiplicity of 2, because this is actually x plus 3 squared, or x minus 3 squared when you factor it.
Okay. Thank you.
You're most welcome. And we'll go over it some more tomorrow too.
Okay.
Okay?
Okay.
All right. Have a good rehearsal.
Thank you. Bye.
Bye-bye.